Suppose we wanted to determine how many grams there are in 2 moles of sodium chloride, or how many molecules are in 2 moles of sodium chloride. In this lesson, we're going to be working on conversions between moles and molecules and molar mass. So you remember that moles has 2 definitions. A mole of a substance is 6.02 times 10 to the 23rd atoms or molecules of that substance. A mole also is the mass of 6.02 times 10 to the 23rd atoms or molecules of that substance. So it also equals the mass of 1 mole of a substance. So if we were given the challenge of determining how many grams are in 2 moles of sodium chloride and how many molecules this is, there's a handy chart that we can use that can help us navigate through the process. So if we are converting from grams to moles, or from moles to grams, we're going to use the molar mass of that substance. So the molar mass of sodium chloride, NaCl, equals 1 Na, which is 35.45 grams. And we got that by looking at the molar mass of sodium, 22.990 grams, and chlorine's is 35.45. So if you look at chlorine, it's 35.45 grams. And remember, that's per mole. We add those together, we get 58.44 grams for 1 mole of sodium chloride. So what does this mean? That means if it's 1 mole, then we can set it up as a ratio. 1 mole we know equals 58.44 grams, and that also equals 6.02 times 10 to the 23rd molecules of NaCl. So we can set up the first ratio as 1 mole equals 58.44 grams. And that's the same thing as saying 58.44 grams is 1 mole. So it's similar to what we did earlier in the year with factor labeling. Earlier in the year we used conversions that were more measurable, that we've had more experience with. The only difference is it's the same exact process, it's just using different numbers and different ideas. So remember when we said 1 foot equals 12 inches, we could write that as 1 foot over 12 inches because it's a ratio, and that equals 12 inches over 1 foot. But both of them equal 1. So in that same way, both of these are going to equal to 1. Also, we say that 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. So we can write that as a ratio. 6.02 times 10 to the 23rd molecules of NaCl in this case, and that equals the other way around. 6.02 times 10 to the 23rd molecules is equal to 1 mole. So we can go from grams to moles using molar mass, or moles to molecules using Avogadro's number. And likewise, go from molecules back to moles. So, in figuring out this problem, you always want to write down the given and unknown. So for the first part of the problem, the given is how many grams, excuse me, just kidding. The given is 2 moles of NaCl. The unknown is how many grams. So you're going to start with the given always, as we did before. And then you're going to refer to your handy dandy chart that you will memorize. And remember, this is over 1. And you're going to have to multiply it by a conversion factor that goes from moles to grams. So if we go up here from moles to grams, we have to use molar mass. Since moles is on the top here, we figured out the molar mass earlier. The molar mass is 58.44 grams. So 1 mole is going to go on the bottom. 58.44 grams on the top. Moles cancels. And you're going to say 2 times 58.44 equals 116.88 grams per mole of sodium chloride. So if a recipe on some other planet calls for 2 moles of sodium chloride, then we are not able to, we don't have any device that measures out moles. We only have scales that measure out grams. And we'll be doing this in the lab with Rice Krispie treats, making Rice Krispie treats next class period. So please make sure you bring in whatever is assigned to you. We would measure out 116.88 grams of table salt, which would make a lot of cookies. All right, so part 2 of this question says, how many molecules is this? So in part 2, the given is 2 moles of NaCl, and the unknown is how many molecules. So again, you're going to start off with the known, 2 moles of NaCl. That's over 1. And then you're going to multiply it, going from moles to molecules, you're going to multiply that by Avogadro's number. So since mole is on the top, you're going to have to use the ratio where 1 mole is on the bottom. 6.02 times 10 to the 23rd molecules is on the top. Moles cancels, and so you're going to take your handy dandy calculator. 2 times 6.02. Remember that when you're dealing with exponents, you find the EE. In this case, it's behind the inverse x function. So second EE, so that means times 10 to, so you don't need to punch in times 10 to. 23 equals, and of course you are going to keep this in scientific notation. That is 1.20 times 10 to the 24th molecules. So these are both one-step problems. We can also do a 2-step problem going from grams to moles to molecules. So let's say that we are looking for how many grams are in 2.59 times 10 to the 25th molecules of, let's use a strong base, sodium hydroxide, our friend sodium hydroxide. Well, naming rules, of course, are going to follow us for the rest of our experience in chemistry. So the first thing you need to do is figure out what is the chemical formula for sodium hydroxide. You know that sodium, being an alkali metal, has a +1 charge, hydroxide a -1. So you will need 1 sodium for each hydroxide, and it's going to be NaOH. So looking at our handy dandy chart here, we will be figuring out how many grams are in this substance by first having to convert. We start off with, the given is 2.59 times 10 to the 25th molecules. And the unknown is how many grams. So we're going to have to go from molecules to moles first. That will be the first step, using Avogadro's number, and then from moles to grams using molar mass. So starting with the given, 2.59 times 10 to the 25th molecules of NaOH over 1 times, so we're using Avogadro's number, we're going to have to use the ratio of 1 mole equals 6.02 times 10 to the 23rd molecules. Since molecules is on the top here, we're going to put molecules on the bottom. And 1 mole on the top. And then we're going to multiply that by, molecules is going to cancel. We're going from moles to grams, and so we're going to have to use the molar mass of sodium hydroxide, and sodium is 22.99. Oxygen is, there's only 1 oxygen and it's 16.00, and there's 1 hydrogen and it's 1.00. We're going to add all those up. 22.99 plus 16 plus 1 equals 39.99 grams per mole. Okay, and so now we have the molar mass. We have moles on the top here, so we want 1 mole on the bottom here, and 39.99 grams. Moles cancels, and you're going to multiply everything on the top. So 2.59 second EE25 times 39.99 equals, and then that answer divided by 6.02 second EE23, enter. So it looks like we're going to have 1720.5 grams of sodium hydroxide, which is quite a bit. It can do some damage. Alrighty, so now it is your turn to practice and enjoy this unit. Okay.